With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, we have a question today. To mop clean a floor, cleaning machine presses a circular mop of radius r vertically downward with a total force of F and rotate it with a constant angular speed about its axis. If force F is distributed uniformly over the mop and the floor is of coefficient of friction, that is mu. The torque applied, we need to find the torque applied by the machine on the mop. So first of all, we will analyze the given situation. We have this mop, and in this mop of radius r, this is a mop and vertically downward equidistributed force F is applied, and this mop is on the surface of the floor, and the coefficient of the surface is mu. So for finding the torque, we need to take, because there is a part of a distribution, so we need to take a small dx strip with radius x So this is what the strip we have taken, and then we will find the smallest differential part of the torque required in this strip. So for solving, we have a differential torque which is equal to mu F. This is the friction force. Why the friction force? Let us see that this is the strip, and this strip experiences a force F. Now the normal force upward is equal to F only, so the friction force is equal to mu N, which is equal to mu F. So this is the friction force we will use.
We always must remember that this friction is on the surface, parallel to the surface and normal to the direction of vertically applied force. So this friction is only involved for creating the torque by the machinery.
So we have written the friction force involved into the normal distance x for finding the torque. So this is what we have, this distance x. Now the ratio of the area involved for this strip is 2 pi x dot dx upon the full area, that is pi r square. Now on integrating this expression from 0 to capital R radius, we are getting the total torque required by the machine, which is taking the constant values outside, which we have 2 mu F upon R square. Pi will be cancelled out, and we are remain with the value as x square dot dx. So on integrating, we are getting the value 2 mu f upon r square into r cube by 3. This is the value we are getting after applying the limits. So our answer is 2 mu f r by 3. This is the expression of torque required by the machinery. So our correct answer is option D. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.